Hey guys, welcome to CodeChef's YouTube channel. The problem that we are going to solve today is Alice versus Bob Face-Off. The problem appeared in September 21 lunchtime and is a difficulty level of easy. There are no prerequisites to solve this problem. The problem statement goes as follows. Alice and Bob have got an integer n. Now to decide that who is going to be the winner, they decide to play a game. So the game goes as follows. Definitely they are going to make alternate moves in the game and the game will go on until n becomes 0. Okay, so n is going to be some positive integer initially and the game will go on till n becomes 0. Now during each turn what a player can do is make one of the following moves. First option is that he has to choose an integer x such that x can be expressed as 2 to the power y where y is greater than or equal to 1. It means that he has to choose an x such that x is a power of 2 and at the same time x should also be a factor of n. It means that n should be divisible by x. And after choosing such an integer, the player will divide n by x. So for example, if the number n was 24 and some player, let's say Alice or Bob, decides that okay, he wants to choose the number x as 8 because it is a power of 2, as you can clearly see, and also x is a factor of n. So what the player can do is at the end of this move, he can change n to 24 divided by 8, that is 3. Okay, so this is one possible move. Another one is if move 1 is not possible. Okay, so remember, if only if move 1 is not possible, only then he is allowed, the player is allowed to subtract 1 from n. It means that this clearly implies that if the number is odd, then you have no other option but to subtract 1 from the number. So let's say if the number n was something like 27, then you have no other option but to make the move and change the number n to 26. Okay, so these are the possible moves that we can do on the number. Now the question is that we have to predict the winner of the game if the game is played optimally by both the players. It is also given that Alice makes the first move. It means that Alice is the one who starts the game with the given number n. So this is pretty much the question. I hope you guys have understood it. Now let's see the solution approach. The solution approach goes as follows. First of all, let me clear out some things that I'll be using while explaining the video. So over the course of the game, we will start with the initial given number n and the number n itself is going to change until it becomes 0. But I am going to call it using the same name, that is the variable n only. So don't get confused with that. Whenever I say n, it means whatever is the current value of n. Okay. So with that, let's begin the solution approach. Now, we have to do some casework in this question because the game is going to go to some states. So what do I mean by states? Now, a state is basically the current situation of the number. Okay, so let's say there is some particular characteristic of n at which, okay, this is some particular characteristic of n which ensures that it is a winning state. What does that mean? That no matter which player lands up on this number, may it be Alice or may it be Bob, he is guaranteed that he can win the game from there. Okay, so such a state is called a winning state. Now our task is mainly to find if there exists some winning state in the question. Okay, and that has to be done using casework. So let's begin with the casework. I'll just remove this part. Okay, so there are three basic cases that you can deduce from the question, which are pretty simple. First, easiest one, that is if n is odd. Okay, at any point if n is odd, the player does not have an option. There's only one thing that the player can do, that is he has to do the second kind of move, that is change n to n minus 1. There is no other option. The player does not have any power with him. He does not have the control over the game right now. Just he has to change the value of n to n minus 1 and the next player has to play. Now the other two cases, n is even. So there is one case, the first one, in which n is maximum divisible by 2. It means that first of all n is even over here. Okay, so in both these cases, in first case n was odd, so definitely in the second case and third case n is going to be even, because if a number is not odd, it is definitely even. But in this case, okay, this second case, what I'm saying is n is maximum divisible by 2. It means that although n is even, it is only divisible by 2. It is not divisible by higher powers. Higher powers like 4, 8, 16 and so on. Okay, so 2 is the highest power. So 2 is the highest number by which it is divisible. So this is one case. And the third case is that n is divisible by 4. So if n is divisible by 4, it definitely means that n is even, and also n is divisible by 2. So these are the three cases that we have. In the first case, in the first case, we saw that there is no power with the current player, so he cannot control the game. Whoever lands at an odd number cannot control the game. Again, check the second case. Does the second case give any extra power to the player? No, it does not. Why? Because if n is divisible by 2 and only divisible by 2, that is 2 is the maximum number by which it is divisible, then the player does not have an option. The only thing that can happen in the game is n is going to be changed to n divided by 2. Why? Because you can only do the second move if the first move is not possible. But here, definitely the first move is possible with according to the problem statement. So again, no power over here. By no power, I mean the player does not have any power with him. He cannot control the game. Again, here we have no power because there is only one move that you can do. You can just divide n to n by 2. Now, the third case is the one in which the player has a power with him. That is, he can go to a winning state definitely. Now, why can I say this with surety? So, my claim is that if n is a number which is divisible by 4, then whichever person lands at such a number n is the guaranteed winner of the game. Why can I say that? That is my claim. Okay, so why can I say that with surety? Say that n is divisible by 4 does not mean that n is not divisible by higher powers. Let's say n is divisible by the highest power. Let's call it 2 to the power y. So I'm going to go over here. Say 2 to the power y is the highest power of 2 that can divide n. So what is the maximum possible move that the player can do? The current player can change n to n divided by 2 to the power y, or he can change n to n divided by 2 to the power y minus 1. Okay, basically any power of 2 that is less than or equal to 2 to the power y, because this is the greatest one. So what will happen is that let's focus on this number, n divided by 2 to the power y. Now there are only two options. Either this is a winning state or a losing state. Okay, either this is a winning state or this is a losing state. We don't know for now. Okay, but the players are playing optimally, so they definitely know which is a winning state and which is not a winning state. So if this is a winning state, then what will the current player do? So let's say the current player who is on n is Alice. Okay, so if he does this operation, then who lands on the winning state? Bob lands on the winning state, and Alice doesn't want that because Alice wants to win himself. So what he will do? He will not allow Bob to land on this state. How? He will just do the second operation. He will go to one lesser power of 2. Like, to give an example, uh, if we have a number, let's say the number is 64, or no, let's say the number is 28. Okay, so the highest power of 2 which can divide 28 is 2 to the power 2. right? Because 28 is divisible by 4. So we have an option to go from 28 to 7 directly by dividing by 4. So here we don't know whether 7 is a winning state or losing state, but the players know. So if 7 is a winning state, then what will Alice do? If Alice is over here currently on the number 28, then he will not divide by 4, because if he divides by 4, then Bob will reach on the winning state. Rather, what will Alice do? Alice will say that okay, if 7 is a winning state, I'll put Bob in such a situation that I will land at 7. So what he'll do? He'll divide the number 28 by 2 and go to the number 14. So now Bob has only one option, because 14 is divisible by 2 and the maximum power is also 2 to the power 1. So Alice will again land over here. So basically what you can see is that Alice can force the other player to make a move such that Alice is in a winning position, and vice versa. Okay, the player actually does not matter. Whoever is here is going to basically win. If Alice is on 28, Alice will win. If Bob is on 28, Bob will win. So the solution is pretty simple. There are only three possible cases. If the number is odd, if the number is even and it is maximum divisible by 2, if the number is even and it is maximum and also it is divisible by 4. Okay, so in this case we have a guaranteed winner. In this case there is no option, we have to just divide n by 2, and in this case we have to just divide n, we have to just subtract 1 from n. So this completes the solution. Now you have to just write a recursive code that implements the same. The code goes as follows. We have a function that tells us the winning state or not. So we just call the function after taking the input n. If win of n, then we see out Alice, because remember Alice is the first person who starts the game. So I start with n and I assume that whatever this function returns, it is with respect to Alice. That is, if this function returns 1, it means that Alice wins, or else Bob wins. So in the function you can see that there are basic cases like if n is equals to 0, return 0, because whoever reaches 0, that's a losing state. If n is odd, you cannot do anything, so you have to just call win of n minus 1. But you will notice that I have reversed the answer. I have done not win of n minus 1. Why this? Because when you are doing n minus 1, the turn is being passed to the next player, right? They are playing alternatively. So we have to negate the answer over here, because if current Alice was playing, then the next turn Bob will be playing. So you have to negate the answer. So that is done over here. Otherwise, in these two lines, that is line number 9 and 10, we definitely know that n is now even, because if it was odd, definitely the answer is calculated over here only. If n is even and it is not divisible by 4, it means that it is only divisible by 2. So you just call win of n by 2 and again negate the answer. Or else line number 10, if you reach line number 10, it means that n is an even number and it is divisible by 4. So you just return 1, because that's a winning state. Okay, so that completes the solution. I hope you guys understood it. If you have any doubts, you can ask them